Let me get to the presentation.
The broadcast is now starting. All attendees are in listen-only mode.
So good morning, everybody. Good afternoon, good night, or wherever you are on the planet. My name is Denis Tanguay. I'm the Executive Director of EVO, and I'm glad to welcome you to this webinar on Retscreen Expert. Just a few words on EVO first, for those who do not know us. EVO is the world's only organization solely dedicated to a mission of providing tools to quantify energy efficiency business transactions. EVO's products and services cover a broad spectrum of energy efficiency and M&V related activities. These projects often have overlapping issues which create a unique set of synergies between our development teams, mainly on the IPMVP committee, and partners in the field as reflected in innovative M&V approaches and continuously reflecting industry's best practices. Our vision is to create a world that has confidence in energy efficiency as a reliable and sustainable energy resource. And our mission is to ensure that the savings and impact of energy efficiency and sustainability projects are determined through appropriate measurement and verification. For today's webinar, we have two presenters, a team of two. The first presenter is Stephen Dixon. Stephen has for over 30 years now provided energy management services to a diverse range of industrial, commercial, institutional, and utility organizations. Broadly recognized as a leader in energy management training, his focus is simple: to empower all that he works with to use energy more efficiently by developing individual skills, organizational best practices, and providing tools for energy management. Stephen has extensive energy management experience, including 800 plus energy assessments, over 1,900 energy management workshops, and has inspired over 25,000 individuals for more than 1,000 organizations. Stephen holds a master's degree in systems design engineering from the University of Waterloo and a Bachelor of Physics from the University of Prince Edward Island. Our second presenter is Kevin Book, Senior Engineer at Retscreen International. Kevin is part of the outreach team of the Retscreen Clean Energy Management Software at Natural Resources Canada's CanMet Energy Research Centre in Varennes, Quebec. He's been involved with every aspect of Retscreen, including development of the power, industrial, commercial, institutional, and residential archetypes, helping customers use the software, delivering training seminars and workshops, developing online distance learning tools such as the e-learning channel, e-textbook, and case studies, and even some software development. Prior to joining NRCan, Kevin worked as a wind energy consultant specializing in the assessment, computer modeling, and performance analysis of wind energy systems. He has been working in the energy field since 1999. Kevin obtained a Bachelor's of Engineering degree in mining engineering from McGill University. So, gentlemen, the floor, just before you go on, I'd like to remind you that at any time during the presentation, you can write your question in the question dialog box in the control panel, which should appear at the right of your screen. Make sure that you do not write the questions in the chat room if you do have access to that. For the webinar today, I'm very happy to report that we have a full room with 500 registrations. The bad news is it is very likely that we will not be able to answer all the questions. However, all the questions written in the question dialog box will be recorded and the Retscreen team will follow up with you afterward. Also, the webinar will be recorded and we will make it available in the subscribers section on our website in the next few days, along with the PowerPoint presentation. Finally, you will receive a short survey after the webinar via email. We would appreciate if you can take the time to complete it. It should not take more than 1 minute. So on that note, Steve and Kevin, the floor is yours.
Good morning, everybody. This is Stephen here. I'll start off here a little bit, and Kevin and I are going to kind of have a conversation going back and forth, share with you some of what we've done with Retscreen with respect to measurement verification. I'm going to let Kevin start off in a couple of minutes with an overview of Retscreen and its features. Some of you are probably familiar with it, some of you may not be, and we're going to try to bring us all to the same point. Then I'll take a few minutes and talk about the relationship between Retscreen and IPMVP, i.e. the 4 options for measurement verification and how we would approach those in Retscreen. Then for the bulk of the remainder of the workshop or the webinar, we'll be looking at examples of each of options A to D applied in Retscreen. So we'll look at a basic lighting retrofit for option A. In option B, we'll look at a lighting retrofit with controls, which obviously change the hours. Under option C, we'll use another aspect of Retscreen to analyze a boiler retrofit and see the idea of establishing a baseline and determining savings with both a QSUM chart and an MMV chart. For those that haven't seen a QSUM chart before, we'll introduce you to that. Very powerful tool, a good companion, great companion to the MMV chart in terms of determining savings and being able to keep an eye on what's happening. And then finally, option D, multiple ECMs. Retscreen does have a simulation capability, so we'll be looking at calibrated simulation, a simple example there. And then I'll finish off with a final example, which is outside of the 4 options, but the idea of using Retscreen for performance insurance. We'll take a look actually at a hospital that retrofitted their boilers with heat recovery, and I'll tell a little story around how they didn't realize what It's going to be a pretty full webinar. As Denise said, please put your questions in the question box. And again, if we don't get to all the questions, we'll do our best to get back to you afterwards with some answers. Over to you, Kevin.
Thanks, Stephen. So I'll spend just a couple of minutes situating you in Retscreen, and for those of you who maybe haven't seen Retscreen before, what it looks like, and to sort of go over some of the features. So I now have the software open on my desktop, and when you download and install the latest version of Retscreen, we just released a new update at the beginning of February. We now have Retscreen version 7 out, Retscreen Expert version 7. And so when you load the software and you open the home screen, this is what you are presented with. And whenever I start any project, I always pause for a moment and just sort of situate myself and sort of what I'm actually trying to do. Retscreen can do a lot of things, so it's important to understand sort of where you are so you don't get lost. So this workflow diagram, the circle that we have in the middle here, shows on the outer ring the types of projects that you can do, and it's echoed here in this left-hand menu. So you can do a benchmark analysis. You can do a feasibility type of analysis, a performance analysis, and you can do them all. So, and the reason is, you know, often we'll start at one of these. So you might start by collecting data and do a performance analysis, and then that leads you to say, well, how am I comparing to other buildings of a similar type? Once you do that, then you say, well, now I want to improve that, and so you will evaluate the feasibility of those projects using the feasibility analysis. And then, of course, and especially pertinent and relevant to what we're talking here today, is once you do those projects, you then need to measure those performances. And so this circle sort of shows you the flow on how those all link together. And that inner circle there shows the various parts of the model, and these will either be display or hidden depending on what we're doing in the software. On the right-hand side here, we have the various lists of types of projects. So some of you who may have heard of Retscreen from a while ago are familiar with it for its renewable projects, and Retscreen still can do that. So Retscreen for power plants. But there's a lot of other things that you can do with Retscreen. So we have a CHP model, cogen, district heating, district energy model. That's also just been updated into this version 7 of the software. So check that out if you haven't seen that already. And then from a facilities or energy efficiency measure standpoint, you can look at whole buildings or parts of buildings or parts of facilities or individual processes for industrial buildings, commercial institutional buildings, schools and hospitals and malls and shopping centers and universities and so forth. Residential buildings, whether it be a single family home or multi-unit high-rise, even agricultural facilities, so barns and poultry facilities and greenhouses. And then I'm using the word facility here, but really anything that consumes any type of energy you could do. So street lighting, we have a lot of municipalities that are doing it to monitor and measure the electricity for their lighting in parks and along the streets. And then also looking just at individual measures. So we'll actually be looking at this in a minute. So you don't have to look at a whole project. You can look at just down to a single light bulb or a pool or just changing a motor, for example. We've also recently added fleet management. So looking at the energy for your fleets. So the gas and the diesel and the various fuels combined consumed for your, whether it be, off-road, on-road trucks, even airplanes and boats and so on and so forth. And one thing to clarify, I think, as well, is Retscreen can be used both for new construction. So if you're trying to do the analysis for what will be the payback of having sort of more efficient projects or more efficient technologies installed, and also for retrofit analysis. So energy audits and looking at, well, what if we have an existing building and we want to change some things out, either for energy efficiency or because they're at the end of their useful life or other. This right-hand column here says some of the things that are in the software. So a lot of this requires, takes a lot of data. And so we have a user manual, we have an e-learning channel, which is quickly building out with a lot of videos on there on how to use the various parts of the software, and we'll keep adding to that over the coming years. We have a product database to fill in, whether it be a light bulb or a PV panel or a motor or building out defining what a wall is and calculating the R value for that. We have a cost database that's updated on a regular basis, including the cost for installation, O&M, etc. We have a benchmark database that includes thousands and thousands of data points for benchmarks for all sorts of facility types around the world. And of course, we have climate data and weather data. Climate data being the long-term averages for over 13,000 locations around the world. And weather data is sort of more near real-time daily data that you can stream in directly from NASA when you're doing performance analysis. And we can show that a little bit later. And then we have a couple of reporting options, including a new dashboard that we've just included. So, so that's Retscreen, and this left-hand side here is how you're going to start your project. If you're doing a full facility, often the virtual energy analyzer is a great way to start. We have a ton of archetypes. Archetypes are full facility models, including full costing. That is a great way to start a project, and then you can go and adjust it to match your building. And you can also start with blank worksheets for the various types of projects as well. And so far, I've only been talking about individual projects, but Retscreen more now recently, over the last 2 years now, has portfolio analysis abilities. So doing this workflow for multiple facilities and aggregating that analysis. So that's what's called a portfolio analysis. We won't get into that today, but we have a couple of videos online about that in the software. So let me show you now just sort of the breadth and the depth of what you can do with Retscreen. So this slide here is a matrix that shows the relationship with what we call how much data you have available for your analysis in what we call the Retscreen Enterprise Initiative. So Retscreen Enterprise is something that we call when we're working with owners of multiple facilities to help them get and use Retscreen for their energy management, sustainability management, and not just for a single building, but for that portfolio. And so it's all anchored at the top left corner here, which is called Retscreen Connect. And Retscreen Connect is our API, our application programming interface that allows us to quickly automate and systematize the data importing from those energy bills and your meters into Retscreen, so that your analysis is done quickly. You're not spending all your day, massaging Excel files so they fit into your the right calculations, that you can actually focus on managing energy. And as I move from left to right here in this table, what I'm doing is I'm adding more and more data. And so if I start here in this middle row, which is for an individual facility, so say a project, let's suppose we have a building, you can start by using just the virtual energy analyzer, getting one of those archetypes in and start defining your building, start describing it, where it is, what's the climate data, and who's responsible, and start naming it properly, and what's the square footage. And then as you start adding information, doing a benchmark analysis, what do other schools, what do other hospitals, what do other elementary schools have in terms of their energy use and intensity. And then once you start collecting data, collecting annual data, monthly, actual, billing data, you can start monitoring that and do consumption or production monitoring of that. And then normalizing that data and even start collecting more fine-grained data, daily data, and normalizing that and doing M&V. And then, of course, you do these things because you want to track the energy performance, but you also want to improve over time. And then so you can go into the feasibility analysis and start determining which projects you want to focus on next and what the payback of those will be, and get predictions in terms of what the energy savings would be for that. And that's that middle row here, which is for an individual facility. But of course, this bottom row is for multiple facilities. So each of these steps I can aggregate over multiple facilities, doing portfolio-wide analysis and ranking your buildings in terms of how their performance, portfolio tracking and aggregating the various, according to the various fuels and years and building types, and doing portfolio performance analysis. So what's the aggregate savings over multiple buildings? And then also planning out what projects you want to do next. So before we jump into the software with examples, are there maybe, I'm looking in the question section here, any specific questions about the Retscreen as a whole? I see in the question panel that a lot of these questions have been answered already. So as Denis said, if there's any other questions, please write them there and we'll get to them a little bit there. I see one from that says, how does a new building analysis compare to standalone building modeling software like eQuest, etc.? That's a great question, one we get a lot. So Retscreen is a companion tool to these other modeling tools like eQuest or Hot 2000 or any of the Energy Plus ones. It's very important to understand the spectrum of energy software analysis. So you really need, Retscreen really is a decision-making tool. It's there for the facility owners to help you decide whether you do a project. I would say it's a mistake to go down and do a very detailed second-by-second hourly simulation of a whole year for a project which may only have a payback of $200, or you don't even know if it has a payback. Run Retscreen first to determine whether it's justified to do that. We have a lot of people who use eQuest or Hot 2000 in collaboration with Retscreen, but using them properly. So eQuest will help you determine, in terms of compliance to standards and building codes. But before you get to that, you want to sort of explore your options. You can do that with Retscreen. So they're companion tools that can be used at different phases of the project. Let's now jump into getting an overview of the IPMVP options that you can use with Retscreen.
So I'll jump in here, Kevin, and just very quickly, many of you are going to be very familiar with this. Obviously, the 4 options available for measurement verification within IPMVP, and we are going to use these as kind of an anchor point today. The idea of retrofit isolation, option A, key parameter measurement, so not measuring everything, but measuring a selected set and making assumptions and calculations around other parameters. A higher degree of uncertainty than B, which is the fully measured retrofit isolation with all parameters measured. Obviously, that's going to take more cost, more effort, but at the same time reduces uncertainty. We'll focus quite a bit on the whole facility option C in Retscreen today, because the performance analysis tools of Retscreen are very adept at performing this kind of analysis, and we'll even show the statistical measures that are generated as well, and in terms of understanding the uncertainty in your model. And then finally, the idea of calibrated simulation. That is where you don't have meter data for a building before, but say, for example, we retrofit a building, and as part of the retrofit, we put meter data in, and we calibrate our model to the a simulated model of the consumption of the building to the post-retrofit consumption, and then we back out the measures that we implemented during the retrofit to then give us a model of the base case situation, which then allows us to take a difference and from there determine the savings or state the savings on that basis. So we'll take a look at each of these 4 examples within Retscreen. I think, Kevin, we've got a bit of an outline here in a minute of which features of Retscreen, which you've already talked about, performance and feasibility and so on. On the next slide, I just want to make a point. I'm referencing this again back to IPMVP. If you can slip the slide there, Kevin, that there really are 2 types of savings. Are savings stated as normalized savings or avoided energy use or avoided consumption, avoided cost? In Retscreen, we are largely going to focus on the first type here, that is avoided energy use and then hence avoided cost. So stated under the conditions of the reporting period, but measured against the baseline performance. So just to reference us in this, again, using IPMVP as our reference here. So, Kevin, over to you in terms of, and actually later on in the webinar here, we'll actually share with you a paper. Some of you may have seen it already. It gave rise to this webinar. And in that paper, Kevin actually sort of broke down how energy or would be M&V'd using Retscreen, and that's actually the next slide. So we'll give that paper a reference later on. I think it was in the announcement for the webinar as well. Kevin?
Yeah, thanks, Stephen. Yeah, so the genesis of this webinar and the paper that it comes from is so one of my roles in Retscreen is to help customer support. When you write to our general Retscreen inbox, I'm one of the people who gets those emails and reads them. And over the years that I've been working in Retscreen, as M&V has taken off and grown in popularity, and people are doing it more and more, I saw a lot of questions where people would do, often option C, doing the performance analysis, and we had a Retscreen Plus many years ago that came out and did that. But there's the other options in the IPMVP M&V method, which I always when people would ask questions, I would always turn to the parts that I was familiar with in Retscreen to help answer them. I sat down with my colleague, Farah Sharif, and we said, well, is it possible to go through the other options, A, B, C, and D, with the various parts of Retscreen, and that would satisfy those options in terms of determining savings. And what we realized is that as Retscreen has grown over the years, there's lots of different parts of the software that aren't necessarily known to everybody who may be focused maybe on performance analysis and baselining. And so we decided to describe that. And so option A, where Stephen was mentioned, where you have the isolation method, where you're doing an individual measure, where there's a lot of tools in there to use the feasibility analysis, and we'll go through those in a minute. And then in option B, depending on the complexity and how many measures, you can use the feasibility analysis, or you can actually use the data tracking if you're tracking the data for the system, the isolated system, the isolated data for the energy efficiency measure that you're doing. And then option C, Stephen will get into a little bit later, where you're doing data tracking and doing regressions, you know, and he, as he said, the M&V chart and introduce you to the Q sum. And then option D, where you're modeling or simulating the whole building and then calibrating that or harmonizing that with your actual measured data. And so there's ways to do that, and we're going to go through each of those. We're going to so the next part of the webinar is we're going to show an example for each of these 4 options. So let me do that right now. So just as a quick overview, I'm going to jump into the software in a second here. And so for option A, where it's the isolation method, we're going to consider a lighting retrofit. What we're going to do is we're going to switch to a more efficient light source, and we're measuring the watts, the electricity load on the lighting system. We're going to say that the hours of operation, we're not changing anything else. So we're not putting occupancy sensors. We're not changing how often the lights go on and off. All we're doing is changing the lights themselves. And then we'll also get into a brief discussion on the interactive effects of lighting being in a building and how that affects the heating and cooling as well. And then we're going to look at, well, what if we change more than just the lights? We change, say, a control system as well. So in addition to reducing the number of watts, we're also, you know, have reduced number of hours that those lights are on, and we'll measure the power measurement, the energy over time. So let me jump into the software now. So I have Retscreen open, and I have so I'm live in the software now. So what I'm going to do, so we're going to do option A and a lighting example. So what that means is I don't necessarily want to model a whole building. I'm going to do an individual measure. So as that table that I showed before, if you look at that table, option A has beside that feasibility. So I could either start with a blank feasibility, or I sometimes like to use just an individual measure here. So I'm going to click on individual measure on this right-hand menu, and Retscreen will load up a blank individual measure template for me. So it locates the project and puts in some climate data for those of you who aren't familiar with this. We have a couple of videos that describe what's on these various pages. And we can also then go and describe the facility. So in our case, we're going to do an individual measure, and we're going to be changing the lights. And we should probably put in some information here about our particular project. We can even take a picture, say, of down the hallway. And let's suppose we're looking at the lighting retrofit project, changing out some lights in a, say, in a retail space, right? So now the main part of the energy modeling is done on the energy page in Retscreen. And I'm going to zoom this up a little bit just so that everyone can see. And so on Retscreen, you start off and we make sure that we have our electricity and fuel. So a lighting project obviously takes electricity. So we'll make sure that we have our proper electricity rate here, 10 cents. We won't use the schedules quite yet. And we don't need to worry about heating or cooling equipment, but as you'll see near the end of this webinar, you really can build out a whole building, a whole facility using all of these options. We're going to be focusing just on lighting here. So I'm going to go to the step 3 end use on the energy and click on lighting. And you'll see the various individual measures that we spoke about are here. So we could look at the building envelope and ventilation, electrical equipment, hot water, pumps, fans, motors, VFDs, and so on. There's a lot of things here. Let's focus on lights for now. So let's click on lights. And what will happen is Retscreen will load up the lighting submodel. So this is the lighting submodel here. And we have the opportunity to write a description. So we're going to say it's a light retrofit. And this is for the EVO webinar and the retail space. We could put more information. And we have 2 options here, level 1 or 2, basically depending on how much detail we want to put. So here we would, level 1, we just put in the lighting load per unit area. And level 2, we actually get into how we're actually changing the lighting system. So let's stay on level 2 for a minute and let's explore this. So you'll see right at the top, we have a lighting illumination calculator. And so you can change what type of space you have. So let's say retail space, and it will put the suggested or recommended illumination level in lux here. And so let's start filling out the base case. So in Retscreen, when you're doing these feasibility analysis, you define a base case and a proposed case. And the savings is the difference between the base case and the proposed case. So let's suppose that we have a retail space and we've taken our illumination meter and we've measured that there's 600 lux there. And we currently have, say, incandescent lighting. And you'll see as I change some of these values, Retscreen will automatically, from its lighting database, remember I mentioned we have a product database, will automatically put a generic or typical lighting efficiency for an incandescent bulb. And if I click on this product database, I do have access to a whole plethora of various lighting types and lighting data points in here. So there's a couple thousand different areas there. And of course, you can customize that with your own. So let's continue down this base case. I have incandescent bulbs. They're 100-watt bulbs, and there's 1 lamp per each fixture in the ceiling. And I don't have any other losses. There's nothing that I need to worry about in terms of losses. And I go around and I measure, say, my corner of this building, the store, and I see that there's 30 fixtures. And so Retscreen will confirm here that there's a total of 30 lamps being used, because there's 1 lamp per fixture and there's 30 fixtures. And I go around and I know that this building is open for 12 hours a day. So after I've done that, Retscreen is able to calculate that the electricity required for this lighting, these incandescent bulbs, 30 of them, for a year at this usage rate is 13,140 kilowatt hours, right? So now let's do the proposed case. What we're doing is an energy efficiency measure. So let's see what we're going to improve and change out the bulb. So the first thing we say, well, can we get away with a few fewer bulbs if they're more efficient? So we say we're actually over illuminating here. Maybe we really want to keep this at the 500 lux. And we're going to change this by putting in a compact fluorescent screw-in bulb. And again, you'll see that the lighting efficiency is quite a bit higher. We've gone up from 14.7 to 56.7. So you could put in your own value if you have specific numbers that you want, but let's leave that for now. And these CFL bulbs, I look on the box, look on the label, and they're only 25 watts. And so the first thing you'll see now is Retscreen knows now that based on the lighting efficiency and the electricity load per lamp, that it has here the suggested number of fixtures. So I don't need 30 lamps anymore because these lights are more efficient. So it's suggesting that I could get away with 26 lamps. So I'm going to put in 26, and Retscreen will then calculate that I'm within 0.29%, so almost exactly at the 500 lux that I'm targeting. Now remember, so the only thing I've changed here is the number and the electricity load, right? The number of lamps and the electricity load per lamp. So I haven't changed the occupancy, so I'm going to leave 12 hours here in the occupancy, and you'll right away see that Retscreen calculates the electricity load for this proposed case for the CFL bulbs, and it's now 2,847 kilowatt hours. And so the difference between the 13,000 and the 2,000, the base case and the proposed case, is very clearly marked over here in this right-hand column. We're saving 10,293 kilowatt hours, a 78% savings. And so this is briefly the option A in terms of the isolation method, just measuring one thing. We've measured the electricity load from the base case to the proposed case, and we're able to calculate what the savings are. Now, of course, unless these lights are out in a parking lot or in an unheated, say, warehouse or uncooled warehouse or a space like that, what actually happens is that these lights will actually have an impact on the heating or cooling in the space that they're in. So if these lights are in a building, the heating and the waste heat off of these lights is going to have an impact. And Stephen's going to talk a little bit about that.
All right, can you throw me control over here, Kevin? There we go. So hopefully you'll see a nice sunset for a second. And I'm going to basically start off where Kevin finished up. So here's our retrofit. Now, Kevin mentioned earlier that you can, in fact, build a whole building and simulate the entire building. We'll see that in the, whoops, excuse me, I need to show my screen here. There we go. So where Kevin left off, we can simulate an entire building, but what we're going to do in this example, we're going to start out with this single measure that Kevin created, and we're actually going to build the building around it. But in order to estimate the impact of the interactions between cooling and heating, we will not need to build an entire building. We simply need to create a valid heating and cooling load within the building, which then these lights can interact with. So I'm going to begin by moving up to the electricity and fuel section and just making sure that I have electricity and fuel specified here. So I have natural gas as my heating fuel, electricity as my operating, obviously, the lights, but also will be operating the cooling systems. I need, in order to build out a building, I need schedules. So in this simple example, I'm going to specify a 24/7 schedule where we're heating the building to, say, 20 degrees C, 24/7, and in cooling season, we'd be cooling it to a temperature of 24 degrees C. Now, recall that when Kevin started off this project, he identified that there was a location here, and that location will specify for us climate data. There was a few questions in the question box earlier about can Retscreen deal with different locations. Retscreen has a climate database that covers the entire world. When I move into the option C example, we'll be working with weather data. That is the actual, not the long-term averages, which is what climate data is, but the actual weather data. And again, Retscreen uses a NASA database which covers the entire world and half degree by half degree grid. So wherever you are in the world, you can get data for your particular facility, which is, that saves a lot of time. All right, back into my energy simulation here. The next thing in the schedules I have to do is to tell Retscreen, when does this building move from heating to cooling? Now, this isn't exactly a balance point temperature for heating or cooling. It's akin to it, though. And so in this case, we're going to specify a number of 16. If our building moved from heating to cooling at a higher or lower temperature, we could adjust that slightly back and forth from this point. But this is a good starting point for this particular kind of analysis. So now we have schedules, we have fuels. So now we need to put a boiler into the building to heat it, so I'm going to add a boiler. Retscreen can allow us to provide a lot of information about a boiler, just to show you here, but we don't need all of that for the actual simulation we're going to do. We simply need to know the fuel to heat efficiency of the boiler, so I'm going to use a number like 75%. And Retscreen also makes it easier for us to make our base and proposed case the same, so I'm going to copy base to proposed to make sure these are identical. So now I have a boiler in the base and the proposed case of identical efficiency. Next, I'm going to add a cooling system. I'm going to use, say, a rooftop unit driven by a compressor. We could call this the RTU cooling. And again, as in the case of the air conditioning system, I don't need a lot of information, but just the key information as to the performance or the efficiency of this particular piece of cooling equipment. I can specify it as a CR ratio or as a COP. If I'm in doubt in Retscreen as to what these values might be for my particular piece of equipment, obviously if you're doing M&V, you're going to have a lot of data, but just to show you, there is a lot of useful help in here as well. So you can click on the label, and we should have mentioned that Retscreen is available in 32 different languages now. So a lot of this is going to be easy for you if English isn't your first language. So here we see a table of suggested values for COP for a cooling system. So even if you're in doubt, you've got a starting point here. Obviously, if you're doing M&V, you're going to tie these numbers down pretty tightly, but certainly a good starting point in any event. So I'm going to go with a COP in this case of 4.1 because I know that's what it is. I'll dial a 4.1 into the base and proposed case, or I could have used the copy base to proposed. All right, so now I have the schedules, the fuels, the boiler for heating, the rooftop unit for cooling. So I'm left with one thing in addition to lighting. I need to have a heating and cooling load. So the way I'm going to simulate that, I could build out a building heating, I could go into energy and I could build a building envelope and add ventilation, add hot water. But the simplest way to do this for me that I've found is to actually create a ventilation load. And there are a couple of ways to create a ventilation load in Retscreen energy load. One is what we call method one, which actually looks at basically a mixed air system. It has a lot of features in it, a little more complicated than we need in the simple example. So I'm going to click on method two, which allows us to specify simply an airflow rate and a schedule. So here we have system selection. We can pick whether for this particular load we're heating, we're cooling it, or we're doing both. We're going to do both. We have one of these systems, and we can specify our units of measure. So if we like CFM, we can use that. We can use liters per second. I'm going to go with a system that's got 24,000 liters per second, a pretty large system, because I want to make sure that my heating load is greater than my lighting load in this case, and my cooling load likewise. Now, obviously, in the buildings you're in, you're doing the M&V on, and you're calculating the interactions. You need to validate that, but I think this is a reasonable value in this point. We don't have any heat recovery in our base case, and so I'm going to copy base to proposed. So now we have a proposed case as well. Now, we're not changing the system. We could. One of the things we could do here is we could simulate putting a heat recovery system in, controlling airflows with a speed controller. But really what we're after here in this section is to determine a heating and cooling load. And Retscreen has done that for us. Here is our heating and our cooling load. And now we're ready to examine the impact of interactions from our measures being the change in lighting system. So in order to do that, I'm going to go back to my include measure screen. And I see that now I have my ventilation system, and I got some negative numbers here. This is kind of strange. This is a common thing that I have people ask me, why do I have negative numbers for my energy saved in my ventilation? Well, it's because of these interactions. I'm going to go back to my lighting example here, and what I'm going to do is I'm going to set the interactions on these little controls right down at the bottom here of the screen to 0. So I'm going to say, look at this lighting system in isolation without interactions with the rest of the building. And I go back to my include measure screen, and I can see now there's no interaction here. I'm getting the same result that Kevin showed us earlier, right? Energy saved the same. But now, if I go in and turn on these interactions, and I could do it one at a time, I could go in and I could turn on the interactions for heating. So I'm going to go down and I'm going to turn heating in. So I'm going to say that this lighting system 100% interacts. Now, if I know with the type of air handler that I have, maybe the heating loads are extracted before they can contribute to the building heating, then I would use this controller set somewhere in between 0 and 100. But in this demonstration, I'm going to go with 100. And now I see that I've now impacted, right, my ventilation to the tune of 5,684. So I've actually cost myself energy by removing that lighting load, which was contributed to the space heating of the building. And then I can do the same thing on the cooling side. So I'm going to go back to my retail space here, and I'm going to turn off the heating interaction, turn on the cooling interaction, right, and go back. And now I can see that I've actually generated an additional saving. This is energy saved 2,894 kilowatt hours. And if I want to know what that is in terms of what I'm purchasing, I would click over to fuel saved, and that means, right, 2,894 at a COP of 4.1 is 706 kilowatt hours. So I can look at this whether it be at the point of the load or at the point of purchase. Now, I go back into my retail space and I turn both of these on. So now I have both interactions if they're both at play. Many of you would only have cooling, obviously, but it depends on your locale, and you can set the situation up as you want it. So here we see then the electricity savings of 10,223 that Kevin generated with his lighting retrofit, and now we actually increase our energy use on the gas side of it by 5,684 equivalent kilowatt hours, but we save an additional 2,894. So now we've counted for the interactions, and in fact, that would all be rippled through in these calculations. Now, some people would say this stuff's a wash, right? Assume it's a wash, and it may be. Right? But the point is, with Retscreen, you can very quickly determine if it's not a wash. And depending on the jurisdiction you're in, the price of energy for gas or heating and your cooling energy, or maybe it's where you're in a purely cooling environment, you want to take into account that additional and verify savings for the additional cooling load reduction, then this is a great tool to be able to do that. So I guess, Kevin, at this point is probably a fair time to stop, and maybe you've been monitoring the questions here a little bit. So why don't we have a few questions before we go any further?
I agree, yeah. And one of the questions, or a couple of questions have revolved around the fact that we you know, what if you have multiple projects of lighting? And when you do this project, you really will need to rewire if you're actually changing from 20 to 30. And that's absolutely right. We've kept this simple on purpose, but there's even within option A, there's nothing preventing you from building this out and adding more components. So if you can see my screen here, I have.
Actually, I don't think I've given you control there, Kevin. So let me flip back to you. I don't see you on the list. Oh, maybe. Hang on a second.
Monitor 2 there. Everyone should see my screen now.
There we go. Oh, yeah. Okay.
So if you on my screen here, you'll see that the example that you were just working with, Stephen. So we have this one retail light. So one question was, well, you know, I don't want to do, you know, piecemeal my whole building. I have maybe a larger lighting project, and maybe all those lights are sub-metered, and that's how I'm going to do this measurement. So there's nothing preventing you from adding additional components. So just as Stephen added a heating system and a cooling system and ventilation, I can add multiple lighting systems. You'll see here lights, and say this one is the retail space, and this is the hallway, and this is the office space. The second one is the office space, and I'm not adding anything to these in terms of details, but I can have multiple lighting measures, and then if I click in this left-hand menu here, the header for lights, I can get just an isolated view of all my lighting measures here, and so you can get an aggregate view of all your lighting projects and still apply option A to it like that. The other thing that there was a question. The other question was the cost associated with it. So let me go into this retail space. And I really did skip over this, but you know, I have mentioned that there's a cost for a relamping cost, installation, rewiring, and that is all taken into account. I didn't show this database, but if I click on this cost database, we have here, you know, the initial cost for all these different types of lamps, installation, high, medium, low, and the lamp life hour. So that's a huge thing as well. If you're changing from, say, halogen lamps or incandescent lamps with a relatively short lifespan to lamps that have, you know, 40, 50, 60,000 hours, even just the relamping cost for, you know, say a large hotel, just the amount of time it takes to relamp is significantly reduced, and that is part of the cost as well. So that the relamping and the costing is also included here. I have here again a level 1, a simplified view, but I can go down to level 2 and say how much were the lamps themselves, any other cost for example, the electrician, and what the lamp life is, and so on. So I really can get into the weeds, as it were, into the details of my project. And that's just for this, and you can do it for each of your lighting projects and have a complete view of that. Let's move on now to look at option B, which is instead of just changing the lamps, I'm changing the lamps. I've put in a motion control system. There's so the occupancy or the operating hours of the lamps is going to be variable. And so instead of just isolating doing one thing, I'm changing multiple things. And so I've come back into Retscreen here on the home page, and you'll see here that we're going to stay with individual measure, but so far we focus on the feasibility side. Let's now bring in the performance side. So what we're going to do is we're going to start tracking the energy. And so I'm going to show you that I have here a file. Let me just show you. So we've collected some data here from you know, a sub-meter, and this is just a simple example here. So I have some monthly data, but this probably would be you know, daily data for the electricity consumption for this that's isolated. Again, this has to be isolated data for it to be option B. And so I'm going to you'll see here I have the electricity per month. And what I'm going to do is I'm going to now track this in Retscreen using the performance analysis. So I'm going to close that. I'm going to go in Retscreen. You'll notice that I have these tabs up here, data and analytics. So I'm going to go into the data tab. And what I'm going to do is I'm going to add a consumption table. So the first thing I'll do is I'll add an electricity consumption table, since that's the data that I have for the, and this table is going to house or have all the data for that, the sub-meter data that I've collected. So, you know, you could enter this row by row, but, you know, Retscreen has a couple of importing options, and I'm going to import from that Excel file. So I'm going to click on import. Let me just find my window here. Okay, I have import, and I'm going, this is the file here, option B, data for import, and we'll see that Retscreen identifies what the begin date and the end date are and the electricity, and you can, oops, what have I done here? Let me do that again. Let's re-import this data, and Retscreen will identify, based on the columns, the begin and end date, and what's in this electricity column. And so I've looked at this, it's okay. I'm going to click OK, and Retscreen will import this into its data sheet. The other thing that Retscreen has that I like to mention is there's also an event log. So we may, an event log is, and you can import data here, but it's a great way to say what's been happening in your building. So we can say here maybe that this lighting project happened at the end of 2017. In December of 2017, on the 1st, there was a lighting retrofit, right? And we can put in, you know, the status, is it completed, is it paid for, etc. You can add different columns here. So we now have two things. We have our electricity consumption and an event log. So now let's go into the analytics tab, and Stephen's going to spend quite a bit more time, and we're not normalizing this data. I've seen a couple of questions about, oh, what about normalization? We're going to get to that. But let's just analyze this straight as it is. So I'm going to go into the analytics tab, and the first thing I'm going to do is I'm going to create a time series graph. I always like to start with a time series graph just to see the data that I'm working with. And so I pick the electricity consumption, that's the table that I have, and I'm going to throw the electricity consumption into my graph, and I see very clearly that the electricity consumption used to be up here, this monthly data, and it took a precipitous drop and went down here. And we can obviously guess that this is when the lighting project was. But in Retscreen, we can overlay that event tracker. So if I click and overlay, I click this button up here called Event Tracker, and I'm going to click on the events that I'm interested in, and Retscreen will annotate or overlay on the graph the various events that you've selected. And so you can hide or display those, and we can see that the lighting retrofit really does line up exactly with this reduction. But the question is, and for option B, is so what are those savings? And so there's one thing that is important to keep in mind is when we're doing this energy model here, this is on an annual basis. Retscreen is it calculates monthly, but the results are shown in an annual basis. So these savings number here, this fuel saved or energy saved, these numbers are annual numbers. So in Retscreen, when you're collecting the data, the way to analyze this is using, I like to use the annual bar graph. So I'm going to do an annual bar graph here. I'm going to take the electricity consumption that I had. I noticed that this data starts, it starts on December 1st. So I'm going to use the December 1st. I'm going to click on OK. And we'll very clearly see here what this is an aggregate of the data that we saw in the time series. The first year of operation, we had the 13,140 kilowatt hours, and the second year is 3,200. And those correspond to the same numbers that we would have seen before. And if we go into this graph, if we add a reference year, so the reference year would be my base case. What year am I want to compare to? I can actually, Retscreen in this table below will calculate what those savings are. 9,855 kilowatt hours are the savings as a result from the difference between the base year and the proposed year. So this is taking a data-driven approach to the option B, and I'm going to stop there so we can move on maybe to the rest of the webinar and maybe answer one or two questions. I see here in some of the questions, you know, people are asking about, can we do lighting controls, occupancy, daylighting, and so forth, and what measurements are made. So that's what I was trying to show there, is when you have multiple measures, probably the easiest way under option B is to simply collect that data, and that's one approach to do it. Remember also there are other options in Retscreen that you can put to do those as well. Stephen, do you think we're okay to move on to option B?
Yeah, we've got about 35 minutes left. Option C and D. I think we need to
option C and D.
Move on. Yeah. Okay, cool. So, so do you like to pass control over to me there, Kevin? You do that?
Sure. Do you want me to go over these slides? Or do you want to go over them?
I can do that. That's fine. Yep. I'll start off, and then we don't have to pass back and forth after this. So.
Okay. Go ahead.
All right.
Oh, hold on. I'm putting you as a presenter. There you go.
Show my screen. Thanks for your patience, everybody. All right. So what I'm going to do is take a look at option C and option D. In option C, the example I'm going to use is the boiler replacement. Now, this boiler had to be replaced because of an impending failure. So in addition to actually establishing a baseline and using an MVP chart to show the savings, to make the savings determination, I'm also going to show how QSUM can be used to support this process. The QSUM chart is akin to an MVP chart. Actually, one can think of it as simply being the cumulative sum of the difference between the actual and the predicted values. So on an MVP chart, the blue and the green lines we have in this graphic, if we just sum those over time, that in fact becomes the QSUM chart. But I'll show you how the QSUM is very valuable detecting change. It's great for finding a baseline. It's good for looking at performance degradation. It also supports strongly the savings determination as well. So once I've done that, we'll take a few questions on option C, and then I'll move into option D and then show you one final example, which is a case study. One thing I should mention in these two examples I'm going to do, all of this is real data. These are real situations. I've scaled it a little bit to protect the innocent, but on the other hand, this is real data. So we haven't fudged this data anyway, just to demonstrate to you how this actually can work quite nicely. So I'm going to move over and I'm going to start a blank version of Retscreen. And I should have that, move this over, here we go. Okay, so everybody see that okay, Kevin? Can you see that? Make sure I've transitioned it over. So I'm going to do a performance analysis. So, and I'm going to do it on a building that is actually located in Brantford, Ontario, Canada. So I need to use the climate data location tools here to navigate over to my particular location. Now, what I'm going to be accessing here is not climate data. I'm going to be accessing weather data. So some notes here. It's important when we put our pin down on the map and when we actually access the particular location that we're cognizant of elevations that are close by, changes in elevation, bodies of water. What we're actually doing is we're placing this pin in a half degree by half degree box. Over the right hand side, you can see the lat and long coming up here, latitude and longitude. But if we happen to be in a box that contains a lot of water, but our building is not over or close to that, then we could skew the data a little bit. So we have to be a little careful in picking our weather station location. So I'm going to lock this weather station in, and I'm going to go ahead and tell Retscreen to figure out where to find that data. So it's actually going to lock it in. It actually brings in climate data, but this is not what I'm going to use in this particular example. So I'm going to do, in this particular example, it is a multi-unit residential building, so I'm just going to set it up for that. And I'm not going to do any benchmarking in this example, and I'm going to do performance analysis. So I'm going to simplify my interface now to focus on location, facility, which we've already done, data analytics, and eventually a report if we need to create one. So I'm going to move over to data here, and the first thing I'm going to do is establish the weather data table, which is empty. And then I'm going to ask Retscreen to go to the NASA satellite database and download as much data as I need. Now, I'm trying to remember how far back I've got to go, but I'm going to go back to 2007. I think my example comes from around 2008 or 9, but I need to make sure I have enough daily. A number of people have asked about data here. This is daily data for any location on the surface of the Earth within a half degree by half degree box. So I'm going to go ahead and cross my fingers and and hope that all the data comes in here. Whenever you go looking for something on the cloud, you always have to have a little bit of faith it's all going to happen, but I think it's going to go well here. And the next thing we hope to see here then is daily data going back to 2007, January the 1st. And it's updating it, and there's our data. So it tells me that there's a few missing values. They're likely in the precipitation column, and what it's going to do is average one day to the next, which is entirely acceptable to me. So I click OK. Now, in this example, because I'm analyzing a boiler, I'm going to need degree days. So the next thing I can do is actually have Retscreen compute the degree days. So I can actually compute both heating and cooling, or one or the other, but I need heating degree days as an example. I can either use an average temperature method for this computation, or I can use, as specified in ASHRAE, a max min temperature method, which happens to be a lot more accurate during shoulder seasons when we're crossing through the balance point. Now, one thing people always ask me, Steve, how do you know what balance point to use? I don't. The building's going to tell me that. I'm going to let the building tell me what the balance point is, and I'll show you that when we get into Retscreen, because there's the tools in here which allow us to find, for the data we have, what the balance point is. And every building is going to have its own unique balance point. So gone are the days of using, degree days to 18 degrees C, which may not work in this building. So here we go. I'm going to go ahead and calculate those, and Retscreen will insert them over here on my first column. So there's the daily degree days. Okay, my next step is to go and get the gas consumption data that I want to work with. So I'm just going to show you the data that I'm actually going to import here, just so you can see. Very similar to what Kevin showed a little bit earlier. Just pull this into context properly. So here's my gas consumption data. So I need a meter reading date, and I need gas consumption. So here we have our gas consumption, right, on a monthly basis. So, and again, one thing I always stress is that the meter reading dates are very important in here. So if you're doing this, don't kind of approximate it. You've got to have it, because you're dealing with daily data in this particular example. Okay, so my next step here will be to actually import this data. I'm going to close this file. I'm going to use a defined import from file, which is a simple way to do this. And I'm going to go and I'm going to grab this raw data file in Excel, and I'm going to pull it up. Okay, now at this point, Retscreen has looked at the data, says I can understand this is the end data they're reading, this is the user defined. I'm using a format for the titles which will allow it to interpret it properly. I'm just going to call this building gas data, just so I have a table that's labeled properly. I always like to use the labels. And Retscreen has even had a crack at actually coming up with the previous reading date, and I'm going to go along with that one. I think that's, or I'm going to move it back one day. Retscreen's pretty good at estimating what that is when I don't give it a begin date, but in this case, I adjusted it by 1 day. I'm going to go ahead and import this. I'm going to tell Retscreen I don't need decimals, and it's interpreted my titles properly. Natural gas meter cubed is the units. Go ahead and check that. And now I have a table which contains the natural gas data. Now, for any of you who've done the next step before, you'll realize how much effort this is going to eliminate. Retscreen will very quickly merge, right, the daily data into the monthly data for the dates that I have here. I'm bringing over the degree days. So the function is merge. We'll click on that, and we're going to specify we want to pull it from that data table from Brantford, which is the weather table we created. We don't want the average temperature. We want the heating degree days, and we're going to go ahead and click OK. And so now Retscreen has actually calculated the total degree days for each of the periods. One thing people are concerned about too is that what if my meter reading dates aren't month ends? That doesn't matter. Use whatever dates they have later in Retscreen. It doesn't even matter if these periods are different lengths, because Retscreen does a weighted regression to deal with the fact that we need to deal with the difference statistically. So Retscreen has all the tools to deal with sort of the nuances and the complications of real world data. All right, so we've now assembled everything properly. Just for safety's sake, I'm going to go ahead and I'm going to save this file just so I have it available for later, project 1, just in case. I always like to do a save. One thing I like to tell people is make sure in the settings feature of Retscreen, you go down here and you save your autosave function, you turn your autosave function on, and you can save previous versions in the file history. Saves you a lot of time in the event that you mess something up and you need to go back and pull it up, or maybe you lose power in your computer. Something goes off, well, Retscreen will actually pull up its autosave file version once you restart, and no fault of yours or Retscreen, but these things happen. So there's some good backup features in here. So we're back to our data page, and now we're going to begin to do analytics. So our challenge here is that we have to find a baseline, and then we have to determine the savings versus that baseline. So Retscreen provides us with a number of tools to do this, but the one I would use typically in this situation is the basic regression analysis. Retscreen now asks me what I want to do regression analysis on. I'm going to use the table that I created called building gas data. It automatically labels my regression for me, which is kind of nice. And it's found the degree days in there, natural gas degree days. So we're good. Now, the last question is duration or daily. And this is where we have to tell Retscreen we're not using data which have equivalent number of days in each period. So this is where we activate the weighted regression feature. If we went with duration, and I see a lot of people doing this first time through, don't do that, because you now need to use a second variable, which is the number of days in the period, to properly do the statistical analysis. So we use daily, and that's going to probably be the norm for most of the types of analysis that you would do. Retscreen does have the ability to do multiple variables. We can do, keep adding to your heart's content. So don't worry that single variable analysis isn't enough for you. Retscreen is more than capable of dealing with those multiple variable situations. And we use them, typically I find we use 2 and 3 variables. I've once used 4, but the technique I use is sort of what I would call, you build it from the bottom up. And so you do a regression with 1 variable, and we'll do a Q-sum. And if we can iron out the changes with the Q-sum, then we know we've dealt with all the relevant variables of influence. And we keep adding variables until we do. So we're going to go ahead and say OK, and here we see our first regression. Now, the first thing I like to do is 2 things. One is I want to have a look at what this data looks like overall, and I'll show you that with a Q-sum in a moment. But the first thing I'm going to check is, what is the balance point temperature for this building? So I can use a Retscreen's feature called Optimize Reference Temperature, where it goes in, it's going to check all the balance point temperatures, in this case between 10 and 20, and it's going to find the best fit between the points and the line represented by the best R-squared value. So I'm going to go ahead and hit Calculate here, and Retscreen will cruise through, and it does a bit of computation here, and it finds, well, this isn't really giving me a final determination. I don't know whether 20 is the highest value here. So just for fun, or actually just for utility purposes, I'm going to click at the 30 and do it again. And what I want to see is, I want to see a curve that kind of tops out. Now, I see a balance point temperature here of 20, not 16, which the data started with, not 18, which many sources provide, but 20. My question here at this point, is this valid for this type of building? Is it valid to have a balance point temperature 20? This is a multi-unit residential building in Canada. This is actually a reasonable balance point temperature. Turns out that other buildings may balance different temperatures, but here we see the importance of actually asking the question, what is the right balance point for my building? And this makes a huge difference to the determination of savings if we don't use the right values here. So I'm going to go ahead and click that. We see it improves our R-squared value. We can also have a quick glance at our statistics here. So we've got a T ratio here on each variable of well above 2. So this is actually a reasonably good model, even as it stands. But remember, this is all the data for 3 years. And we also have a CV value, CVRMSE of 6.9%, which is pretty tight. But it's going to get better. You're going to see it getting better. So there's our scatter plot. We can look at it as a time series. We can look at actual versus predicted. So, this is a pretty good model. But believe it or not, there are savings buried in this data. So the way I'm going to extract them is, I'm going to run a Q-sum chart. I'm going to say, show me the value, the summation of the actual versus predicted value based on the overall model here. That is, so I call this an overall Q-sum, an end-to-end Q-sum, but it's based upon all the data. It's like comparing each point to the average, in a sense, because if you look at your regression line, in a sense, in simple terms, that's the average. So we're actually comparing systematically the difference between each point and the average. And over the course of the data set, if this is the best fit line, then the Q-sum gets to 0, which by definition it has to. Now, the reason I do this is, when I interpret a Q-sum the first time, I'm looking for different segments. And in this one, I see at least 2 segments. I see an upsloping segment and a downsloping segment. Now, we can look a little further. We might say, well, there's an upsloping segment, and then there's a flat segment, and there's a downsloping segment. The one thing I know about a Q-sum from doing thousands of these things is, whenever the Q-sum changes dramatically, there's a physical change behind it. So we know in this building that they actually retrofitted the boiler. We don't really know, or we don't actually know when it occurred, but we can use this tool to figure out when that change point occurred. So a retrofit of a boiler, you would think, would improve the performance and reduce gas consumption. So it would want to be a downturn. So we're thinking that maybe over here on the right-hand side, this is our downturn. But we're really not sure at this point. But what I do know is, the first 12 months, the first year here, is probably on the upslope. So what I'm going to do is, I'm going to establish a new baseline using regression analysis now. Everything's the same. I just accept the parameters I'm presented with. But in this case, I'm going to ask for only the first 12 months in my baseline period. And as you can see, Retscreen is pretty adept at dealing with the data. Now, it's using a balance point temperature of 16 here, and I get a nice R-squared value of 9938. Again, this isn't fudge data. If you think I played with this data, I haven't. This is raw data, came from projects that we worked on. I'm going to check my balance point temperature. So I'm going to go again from 10 to 30 because I know that I want to have a wide enough range to catch the optimum here or the maximum value. Right, and here we see now that the balance point temperature in this case is 0.9938. So for the earlier period, it's actually lower. That actually begs questions. What did they do in this building over time that drove, on average, the balance point temperature up? And maybe it's the fact that the boiler's performance degraded before it was actually replaced. So we'll come back to that one in a moment. So we dial this in. So now we have a 12-month baseline, right, which kind of meets all the criteria for a good baseline. It's got winter and summer fully represented in our 12 points. When we go to our details, we can see the T ratios and the P values are scorchingly good, well above 2 and well below 5%. We now have a coefficient of variation of the root mean square error, or the CBRMSE, of 2.7%. So the precision of this model is pretty darn good. And now we can have a look at our Q-sum chart. When we do this, it takes on a whole new complexion, although behind it is basically something similar. The Q-sum chart here had a segment where it essentially went up and maybe plateaued, headed down. If we look at this one basically is flat, okay? It kind of heads up a little bit, plateaus, and heads downwards. So one of the things, if you've worked with Q-sum before, you'll realize is that when the Q-sum changes, there's probably a physical change. The other thing you'll recognize over time is that you'll become very comfortable using this as a tool to find change. You know, it's not the ultimate determinant of the savings necessarily, but it is very useful in actually parsing the data to find when things are changing, because the best baseline obviously is one where we don't have change, right? We really don't want changes that we have to make adjustments out of, using some kind of a baseline adjustment to deal with things that were changing in the baseline. At this point, we're in a position to run an M&V chart. Now, the question I would have from this Q-sum is, when did the boiler get retrofitted? Well, my bet would be sometime over in this period right here, right? And, you know, I may not know that in advance, but at this point I might say that, well, by the end of December, that new boiler was up and running. So potentially the boiler was commissioned on the 30th of, by the 30th of November 2013. So I could actually go back, as Kevin had done before, and I could add an event log here, right? So I'm going to go in here and I'm going to the what did I say that date was? Just run back here a second, folks. Commissioning on November 30th, 2013. So I'm going to go back here. I'm going to 2013, November 30th, like that. And I'm going to put boiler commissioned. Whoops, excuse me. Wish I could spell. There we go. So now I've created an event in my event log, and now I can go back into my Q-sum chart and I can turn on that event log as Kevin showed us earlier, and now we see the commissioning date of the boiler. Now, if that is when it was, and I would go and obviously verify that this was a project that we weren't involved in, but we were asked to come in and measure the savings for, and clearly we'd have to confirm that with changes in the building. Next step then would be to look at our M&V chart, and in the M&V chart, we can turn on the event tracker as well, and here we see the commissioning date of the boiler. So what we want to do here in the M&V chart then is to move our commissioning date over to the same point. So we're going to go to 2013, November 30th, right, and redraw the M&V chart. So we see our commissioning date corresponding to our arrow, and now the Retscreen is calculated for us in the period, the reporting period following the commissioning date, the savings. Now, if we want the 1 year savings, then we can specify an end date. So we take this up, and so from the end of November for 1 year, and I always have trouble with my dyslexia on this one, but I'm going to have a go at it here. So 2014 November, right, 30th. And now we see a savings of 167,000 cubic meters of gas. Quick check would show us that this is about 12 or 14% of the consumption of this building. So we're kind of above the guideline of 10% for using option C. But even in the event that we were below that, I'm going to encourage people to go back and look at the parameters of their baseline model, the uncertainty in their baseline model related to the CV, because it is possible to move under that 10% as long as we have a precision in the model that's appropriate for doing that. So, but in this case, one way or the other, we've got a good determination of the savings. And there's a pretty quick little demonstration of how to use Retscreen in option C. Now, one thing I want to touch on here quickly is that when we go back to this QSUM here, you know, people might ask, well, why did this thing lift off the axis then level out? And when did this occur? Well, this was in March, April, and May. You know, there's still heating in this building, believe it or not, in those months in this locale. Well, it's probably what happened was the boiler was starting to malfunction and misbehave and obviously increase its consumption of gas. So we could even see that. So if we were monitoring this building, it'd probably be possible to actually see this performance degradation even before the boiler was actually retrofitted. So we could, in fact, could have amplified that. Let's say that our end date, we'll put in November of 2013, the end date for our QSUM. And the one thing about QSUM is that it's a kind of an auto-scaling thing, and so November 30th, when we do it this way, so now we can actually see this period, which is our baseline period, and now we see the liftoff. So again, the capability of the QSUM tool within Retscreen to actually see degradation in performance, right? In addition to the fact that we've used it in here to actually verify savings, I think is a powerful tool. So not just using it once, but using it on a continuous basis as a tool for assuring savings. And I'll share with you an example before you finish your covering off on that one. So Kevin, I'm gonna, I know we've probably got a few questions here, but you can open up the line if you want, but we do have to sort of keep moving because we've got to get through to our final example here. So
yeah. Maybe let's answer two quick questions that have come up a couple of times. So actually, the one is someone wanted to see how you created that M&V chart. So can you just show which button it is, just so that people can see?
Yeah. So basically, I'll just do it for this one. So really, it's just a matter of clicking up here on the ribbon bar under step 4. I'll remove this one here, and just so I can remove this. And then I can, so basically once I'm in the regression, then I look at the ribbon bar up here under step 4, I have QSUM control and measurement verification chart. And if I click that, I get it. And then the controls in there to set the commissioning date and the end date so you can do the 1-year reporting period.
Yeah. The other question that's come up a couple of times is about, well, now that you have this, can you do forecasting? So if you maybe just want to click on the forecast button, and we'll show how that's now built in. That's something relatively new to Retscreen. So once you have your regression, you can then use that equation to then do a forecast. So a couple of people, and it will, well, Stephen will show you here.
So what do you want me to forecast there?
So here our energy driver is heating degree days, right? So we're going to forecast our gas consumption. So if you click, you now have you pick what regression, so what equation you want. And then let's just skip ahead to the next screen here, because the main thing in a forecast is you have to then say, well, what's driving my energy production? In this case, it's weather. In one of the examples in the questions, people will say it's a factory with production. So you need to then say, okay, well, if you're going to forecast, well, what are, you know, look into your crystal ball and what's the weather going to be like, or what's the production going to be next year?
Yeah, so we can go, in this case, I'm just going to do it based on climate data that's available, which would be 20-year average data, right? Because that's the best you could do, right?
Yep.
And then we go ahead and click it, and then we get our forecast for this building based on the model, the regression model that I created over here, which we know. Now, if this building had improved, then we would probably want to base our regression on the period following the retrofit. So if we were going to forecast going forward, I would not use the baseline period over here. I would use the improved period over here. But nevertheless, the procedure would be the same.
Yep. So I think there's a couple of other questions, but I can answer those by email afterwards. So all the questions I don't get to today will, over the next couple of days, I'll go through these, and we're able to export these. So do you want to continue, Stephen?
Sure. What I wanted to touch on now is just using option D. And the way I'm going to do this is I'm actually going to just, I won't go into the details of doing it, just in the spirit of conserving time here a little bit, but I'll show the result here. So just a second for Retscreen to open up our final model. So what I've done here is I've used the virtual energy analyzer to create a complete building model. I'll show you that here. This building model is for a building in Montreal. The type of building is a simple office building, and we do have some benchmark information. So this is a good view of what an archetype would actually present us with, which is a complete building, which we can then go in and tailor and adjust to our situation. So what I've actually done here is I've created a complete building, and in fact, I can use the simulation tool to essentially show savings. I'm going to jump back to a slide here just very quickly. And the approach that we're going to use in this one, you can see the slide is, let me just go ahead a couple of slides here. Here we go. So when we're in an audit or a feasibility or engineering study context, you would basically model your base case, right? And you would calibrate it to your historical consumption. So what the consumption was prior to when you did the audit, or at the time of the audit. And then you, in Retscreen, as we showed before, you would copy the base to the proposed case. So you would then establish the base and the proposed case identically, and then you would speculate or estimate what your savings would be for measures that you're going to include in your audit report. So that's kind of the way we normally do it going forward. But in the M&V context, we're going to use the tools in the same way. But in this case, we're going to model the post-retrofit case as the base case, and in just the same way as we did it with the audit, we're going to calibrate to consumption, but we're going to calibrate to the post-retrofit consumption. So we're going to create a base case and a proposed case that are identical, but they match the proposed case or the post-retrofit consumption. And then what we'll do is simply go back into the base case and remove from the base case the measures that were included in the proposed case, and the difference then between the base case and the proposed case will be the evaluated savings, which is really the same things we did in the audit, but now rather than having a calibrated model in the base case, which you do in an audit, you have a calibrated model in the proposed case. So really, the view of it is no different. We're simply going to use the full simulation capability of Retscreen to actually calculate the energy consumption of a building. But the one feature that's kind of key here, and you've highlighted this in your paper, Kevin, is what we call the verification tool. So here's where we actually enter in the historical consumption, right, which is 48.95, and this is our proposed case consumption. So this is what we've calculated in our proposed case with the conditions we specified. So in this case, we see that we can actually calculate the variance between the proposed case and the base case. And I'm not quite sure why that's a little bit different, but it's supposed to be a little bit closer than that. So, but what we do now is we go back to our include screen, and now what we see as the savings that are calculated, which are also included up here. So the savings here, this is now our savings determination for this building. This is a pretty small building, this example, but this is now our savings determination in heating and cooling. So we're really just using the simulation tool, right? We're calibrating to the proposed case or the post-retrofit as the proposed case, and then we're backwardly adjusting our base case conditions to match the building without the measures in it. So in the case where we don't have gas or electricity or fuel consumption before we actually make the retrofit, but we have it afterwards, then this becomes our method of savings determination. So I can take a look at a simple examples here in the office in the building envelope, see what we did here in this case. All we did in this case was actually change the schedule that the building was operating under. So this is a fully developed building envelope model. And here we have the office base case consumption based upon the base case schedules. And if we're wondering about what the base case schedules will look like, we go over here and we see our temperatures and times, right? And the other thing we changed in here was we actually added solar shading for summer. So in the base case, there was 30 to 50% shading on the northeast, southwest windows, but we've moved that up to 75%, and then that shows the overall impact. And then the other thing we did here was to tighten out the building a little bit, so we reduced some of the air leakage. Now this isn't the entire airflow through the building at 0.3 and 0.15 air changes an hour. This is just simply that which occurs as a function of the leakage around the windows, doors, and the walls. But because we've made some improvements, we've tightened things up a little bit, then we can show the savings in the building envelope. So not only do we see in in the comparison screen the overall savings for this building, but now in the include screen, we can see the savings for each and every measure, and these measures are actually interacting with each other as well, because if we have a lighting retrofit in here, which we do have in the office, then we've got the interactions turned on to the tune of about 70%. We now get a pretty good idea of what the actual interactions with the entire building is. So we've done a simulation on the entire building. So Kevin, that's kind of a very quick tour of option D, but I think at this point we've gone through many of the other aspects. Really, it's a matter of simulating your building, and as most of the people out there know, the quality of the determination in this case comes down to the skill of the simulator and the ability of the tool. So you need to understand, if you're using Retscreen for this, you need to understand the capabilities of Retscreen. The other piece that helps in the reconciliation is this is climate data, right? But we could go back and we could construct our own data, right, for this table from weather data for the actual year of the post retrofit. So, and that way we're actually calibrating to the actual weather that occurred outside the building, as opposed, what I've done here is to the 20-year climate data, which would not be anywhere near as accurate. Kevin?
Yep, that's yeah, absolutely, that's good.
Actually, on that point about the calibration, sorry, there is a really good video that's coming along. Kevin, you're putting that up as we speak, probably, right? Reconciling Retscreen fuel consumption with historical data. So again, there's a number of tools within Retscreen to allow you to do that, making sure you're using the actual climate, the actual weather data as opposed to the climate data. You're normalizing for other variables like production, like we talked about. Looking at the largest user, there's some nice end use pie charts you can use. One thing I like to do is reconcile the heating and cooling electricity total separate, so not just reconcile the total consumption, but that for each of the components, right? We can make sure we take care with the heating and cooling, sorry, there's a typo here, heating and cooling impact, making sure that we set those sliders properly, making sure our schedules are adjusted, and that we deal carefully and properly with the heating cooling changeover temperature. That is the akin to the balance point temperatures. So there's one more example I was going to go into, which is sort of the idea of making sure that we don't lose savings. I'm going to do it right on the slide here. If anybody wants, and we can certainly send this out through EVO. This is a great little example of a building where they didn't even realize the savings they'd made in the building. We went in and started to actually do some analysis on it. We discovered some pretty nice savings. You can see this QSUM line is turning downwards in the slide quite nicely after about the first 12 months. And that was a bit surprising to the folks in the hospital when they put the economizer on. They didn't really realize you could calculate the savings. But the next thing that happened was the whole QSUM line went horizontal. And if anybody knows what that means, it means your savings have disappeared. And after questioning the folks from the hospital, it took about 2 months before the people at the hospital could figure out what happened. And what it came down to was that they'd actually, 11 months in, taken the economizer out for service, put it back in, but they forgot to turn the valves into the service position again. So the economizer was back in the stack, but water wasn't flowing through it and heat wasn't being recovered, and savings had disappeared. But then a couple of months later on their rounds, one of the boiler engineers discovered that, reset the valves. But again, nobody was aware of all this. And I just bring this up because with a tool like Retscreen, it's one thing to verify the savings to begin with. It's another thing to make sure that you have a visual. That QSUM and even the M&V chart for that matter gives you that ongoing visual. And when something goes wrong, you're going to know about it sooner than later. In this case, if they had read those gas meters once a week rather than once a month, and they had to be checking their QSUM chart, they could have reduced the loss in savings, which amounted to about $30,000. That's what they lost. They could reduce that by 75% by just a little bit of simple monitoring. No more meters, right? And using a simple piece of software like this called Retscreen. If you use it to begin with to verify, why not assure savings with it? Back to you, Kevin.
Yeah, that's good. There's a lot of interest, a lot of questions. Some of the questions are revolving around data resolution. So what if I have daily data? What about hourly data? My quick answer to that is yes, we have, for the examples here, used monthly data or meter readings. But as we saw with the the weather data that Stephen downloaded from NASA, the resolution can go down as detailed as daily. We are working in and actually have a couple of prototypes already ready for being able to import hourly data. In fact, if you're, especially your utility data, if it's in green button format, you can import it up, even in 15-minute intervals today into Retscreen. The analysis is done on a daily basis. We're not doing hourly analysis. So the analysis step is at on a daily basis, but the data can be in a more fine-grained resolution, and we're adding tools, and we'll continue to add tools to make that better.
The one question here, Kevin, on the base, in the case for option C, the boiler, is it correct to use the 1-year baseline, or should I have used the 12 months immediately prior, which includes the malfunctioning boiler? That's a really good question. And in fact, when we teach this in a longer workshop, I actually pose that question to students. And one could justify the answer either way, because in fact, if the boiler was retrofitted from a poor condition in the the previous 8 or 9 months, then maybe you should have included that. Either way, you can get a good model there. The reason I picked the earlier one was maybe just for simplicity, but also a change within the baseline period, all right, will reduce your statistics. But it's a very good question, and it's one that you would answer with a qualification. That is, I picked this baseline period. It still meets the criteria for a good baseline determination, and I've picked it because I want to include the poor performance of the boiler immediately prior to the retrofit. Good question. They're all good questions. I just wish we could get to them all.
Yeah.
How do you do a multiple regression with more than one influence factor? When we do the regression page, we simply just click on the little plus sign in the dialog, and we can pick multiple variables. We can add production, we can add occupancy. I've actually had a situation where I couldn't model the cooling in a building because of the large glass atrium area, and I used solar energy, that is solar radiation, on a vertical surface for the direction that particular windows in the atrium were facing, and that became a significant variable in the cooling load in that building.
Yeah, I think there's, maybe we'll take 1 or 2 more questions, and then, as I said, for any questions that haven't been answered here, I'll be sending out emails over the next couple of days. We talked about multiple regressions. So some of the questions are revolving around non-routine adjustments, or and how to label those in the MNV graph. I would say, one of the things is just using that event log. There's been a couple of questions about the event log and how to do that. So, you add the event log as any data table, and of course that can be a data source as well that you can import. So if you have a spreadsheet of a bunch of data, you can import that directly as a event log, and then you can overlay. And one of the fun things to do maybe is to select a bunch of them and overlay them on your QSUM or on your MNV graph, and sort of see what things line up and what show. So here Stephen has a couple of event logs that are lined up on the graph, and that's one way to sort of at least log those.
And in terms of adjustments, there's a couple of ways. There's if we had more time, I could show a backcasting. There was a question about backcasting. And what I've done is I've created a subordinate secondary regression, and I backcasted with that. So in fact, you create another set of data. We can add columns in here, which come from computations within the tool, so we can add and subtract. So we can create a calculated column within our data tables, and we can either manually input the adjustments, say for computers being added to a building, or we can have a secondary regression. Maybe one of the things we could do, Kevin, is through the folks at EVO, we could provide maybe a sampling of different sort of tools that can augment what we've talked about here today, which would answer some of those questions.
Yeah, I agree. Okay, do we want to take more questions, or should we sort of wrap it up? We've gone already a little bit over time. I
just want to show one thing, Kevin. Creating reports in Retscreen is is blindingly easy. You simply click on the create report function in the report, and then you get all of these beautiful graphs and charts. And in fact, you can go in and you can annotate them. You can put your own text underneath. So explore the report function. I think you'll be pleased. I use this all the time for a sort of a production type of assessment methodology we use. So very, very quick, very easy to use, and powerful tool. So use the report function, and definitely part of any good M&V is the good report.
All right, so as far as I know, I think we're getting close to the end here. As I said, if you haven't already seen the article that this is based on, it's on the M&V Focus newsletter. Our emails are up here on the screen if you need to contact us. Also, if you're in the software itself and you go to File, Help, there's a little button there that says Contact Retscreen Support. That comes to me, so I'll be able to answer your questions there. And yeah, we look forward to interacting with you after this webinar. Thank you, everyone.
I'm more than happy to share tools and tricks that I use with Retscreen. I'm a great believer in sharing things. I don't want you to buy them. I'll give them to you. So please ask. That's the email.
Great. So Kevin and Steve, thank you very much for this very interesting webinar. I thank all the participants, and Monica has a final word to say about the survey and how it's going to be sent. So Monica.